All right, folks. Congratulations. This is the last time that you will be starting to write down notes. Rockets does run through 2 days, actually. So we'll be doing this today and we'll be doing this tomorrow. Rockets. As you can see, I'm dressed for the occasion and happy to be so. This is more comfortable than a regular teaching outfit. You can see with this picture, we've got several rockets here. This is the Saturn V. We'll be spending a lot of time on this from the Apollo program. Space Shuttle is pretty common. The rocket that, keep it down, folks. The rocket that most recently took astronauts up into space from the U.S., from SpaceX, that is this guy right here, the Falcon 9. So this is actually taller than the Space Shuttle. Kind of interesting. All right, a little bit about rockets here. Rocket comes from the Italian Rosetta, or however you pronounce that word. Anybody know how to pronounce that word? I don't know. But it sounds like a dish I would be interested in eating. Rosetta. So go ahead, write that whole slide down. Yeah. So the base for rocket comes from the old word that meant little fuse. You do not need to know the year. In terms of rockets actually being used in things like war, that first happened in about 1241. The Mongols, there's Mongolia right there. There's China. The Mongols used rocket-like weapons, keep it down folks, rocket-like weapons against the Hungarians at the Battle of Mohi in 1241. I'm sure you've all heard of the Battle of Mohi. No, you haven't. I hadn't either. You don't have to write this down. But this is the first time rockets were first documented as being used for warlike purposes.
Would they just like throw things?
From the technology in these days, I mean, it would just be like loading something up and just launching it. I don't think you'd have an explosion even at the end. It's just a matter of trying to hit someone really, really far away. Very, very inaccurate. It's not the sort of thing that would be too effective. I don't know if the Mongols won this or not, but... All right. Write down Sir William Congreve. Yeah. You got the little part down the middle there. Very 90s. And greatly improved rocket technology. Write down that bullet point. Just write down his name and that he greatly improved rocket technology. So the main things that this guy did then is rockets before this time were extremely inaccurate in terms of their direction and even going up or across. So he kind of standardized the rocket motor with an iron tube and a conical nose. Of course, without that cone on the top, it's not going to go straight. So yeah, he made that very standard. He came up with a new propellant mixture that helped a lot. and they were labeled Congreve rockets. You probably saw these during 4th of July at one point or another. If you've seen something that looks like this, these are Congreve rockets. Something else that's important to note, in the Star-Spangled Banner, you eventually get to the point where it says, "and the rocket's red glare." These rockets that were exploding above Fort McHenry, those were the source of that part of the national anthem right there. So go ahead and write down just write down this last hash right here. Rockets fired on Fort McHenry were the source of "and the rocket's red glare." Of course, make sure you know those are Congreve rockets. Last official note section, but we do have another day of it tomorrow. Of course, the War of 1812 is where the national anthem came from, the Star-Spangled Banner. So the next improvement that came with rockets is what happens if you try to throw a football without a spiral? It tumbles. It doesn't do what you want it to do. And rockets were the exact same problem. You cannot get a very accurate rocket if it's not kind of spinning. And the guy that came up with that was William Hale. Write down William Hale, and then write down that bullet point. Yes.
What's your favorite unit that Lou created teach?
From this?
Yeah.
Probably Pluto. I really like Pluto.
Okay, would you like Pluto if it was still called a planet?
Yes, but probably not as much. I have a very soft spot in my heart for Pluto on account of that, but it would probably still be my favorite planet and favorite section.
One Earth, not my favorite planet.
Good answer. No. Yeah, don't worry about memorizing the date. So, of course, yeah, when things spin, they remain more stable in the air, whether you're talking about a football or whether you're talking about a frisbee. If you try and throw a frisbee without spinning it, it's not going to go very far, and it's not going to go very well for you. So the same thing's true with bullets, as you can see on the picture here. It spins, and that keeps it stable so it doesn't tumble over itself. Write down Robert Goddard, father of modern rocketry. Robert Goddard, father of modern rocketry.
Are we going to be talking about the V2 rockets?
The V2?
Yeah.
Yeah, those are coming right on the next slide, I think. Maybe that was a style. So Robert Goddard, a very, very important name, probably more important than each of the other guys combined. He really took rocketry to the next level. Everybody else was basically just trying to get him to fly really far and make him sort of accurate. He really changed the game. Robert Goddard is a very, very important person when we're thinking of rocketry. He created liquid-fueled rockets, and the good part about liquid-fueled rockets is the way rockets were powered up until that point was through gunpowder, basically. And when you are launching something with powder, it is extremely inefficient. A lot of that energy goes to just heat and explosion. It doesn't work itself into the efficiency of the actual rocket design. When you go to liquid-fueled rockets, they burn extremely consistently, which is the sort of thing you need if you want to be able to hit a consistent target or get to a consistent location. And by that, he improved engine efficiency from 2 to 64%, which is a huge, huge deal. In World War II, you guys probably, at least I know Tyler's heard of the V-2 rocket. From this slide, you can probably write down German V-2 rocket. This is a big part of World War II. If you're reading the slide, it goes through the rocket, not underneath. So thousands of these were fired at Belgium, England, and France. They were very inaccurate. They did destroy a lot of different places, not just military facilities, but also residential areas. Max range about 200 miles, so about 2/3 of Wisconsin from left to right. And Germany was way ahead of anything the Allied nations had in terms of rocket technology. And they used it to their full advantage, for sure.
Did they all work at NASA?
What's that?
The scientists, they worked for NASA after World War II.
Yeah, later on, you mean? Yeah, I'm going to get to that too. You guys really know your rocketry. This is good.
Now we're just really good.
Just German V-2 rocket, yeah. This is the size, you can see compared with a person there. So it's rather large. And it's kind of interesting because you think of this whole thing as just being a massive explosion when it hits the ground. But the part that actually explodes is not the entire big part of the rocket. The part that explodes is just this top part up here. That's where the warhead is. Everything else is mostly a guidance system and fuel to get it to the location. So that's what was inside of your V-2 rocket. As mentioned, they destroyed a lot of residential areas and other things in those countries. You can see a result right here from an explosion.
If we have time afterwards, can we watch PC Rocket fail?
Yeah, sure. And as mentioned by Jeff, so all those, big name scientists that worked on the German rocketry back in the day, after World War II, were very encouraged to work for the Allied nations, and they did so. So this is a lot of those scientists right here. There's Eisenhower. So thanks to that, we kind of caught up, and that's right here. It does kind of look like him, doesn't it? So yeah.
Next to the pale baby, why does it look like his face doesn't match up?
Who, this guy?
No, right in between.
Here?
Yeah, it looks like he's wearing one of those masks that have you smile.
Oh
The
yeah.
guy right next to him is like super pale.
It's
Yeah.
brighter.
Here, we better fix that. We got to make his face a little more defined.
Oh no! That's one of Clarence's greatest moments.
There we go. Does that make you more comfortable?
Totally.
Okay. Let's do this to someone else. Who else should we do this to?
That looks like when Dwight took the shoes off the baby.
The guy in the middle? Yeah. We're not going to do that to the
It
president.
looks like the baby.
Let's do this guy. He doesn't look quite as happy. There we go.
You get a curl of parents.
like one little.
No, I'm not going to diss Mr. President Eisenhower.
Yeah, don't decide.
He's a good guy.
Don't decide.
Okay.
When did the Cold War end?
All right. As you can tell, everybody loved the Cold War. Okay. Write down this whole slide.
I'm sorry, we want to write Cold War.
The whole thing.
Oh, whole thing.
That would include Cold War.
Is this the hospital?
So a little bit about these missiles. They're much different from the V-2 missiles in several different ways. Number one, they're intercontinental, so they can go between continents. And number two, they've got nuclear weapons. They're not just big explosions that are going to destroy buildings. With nuclear weapons, you don't just have a massive explosion, you've got radiation poisoning and everything that could happen as a result of that later on. So these were a big deal during the Cold War, and a lot of people lost a lot of sleep over them because they were impossible to intercept. They'd go real high, and you wouldn't be able to find them on the radar, and the only thing you could do is, if you saw it coming and had it explode, you'd fire your rockets at the other guys, and you'd have a massive global nuclear holocaust. Speaking of, it's easy to, I wasn't really, the USSR came down in 1992, so when I was about 9 or 10, so I don't remember a whole lot from that period of time, but still, even up through the early 90s, people had that idea in the back of their minds that we still got two countries that did not like each other, and they have a whole bunch of nuclear weapons, and if one launches, the other's going to launch, and that's pretty much the end of the world. World War III would not have a winner.
Have you seen Terminator?
Yes, Terminator 2, I really like, yeah.
The Judgment Day ones?
Yep.
We should watch the end of it.
We should.
Can we? Like, it's like 2 minutes.
Sure, I could probably find that. I have it at home, I could bring it in.
No, you can
But-
just
Yeah.
you just search on YouTube. Just
Oh, and it just wipes them out in the skeletons? So, let's bring it back together for a second here now. So, in terms of the Cold War, these were big fears that people had, and they were legitimate. It's not like you had an army that might invade you. It's like if you saw these missiles coming in, you know it's too late and you're dead. And if you ever want to get an idea, and I actually did this over the summer, if you ever want to get an idea of kind of what it was like living in those times, in the 60s, 70s, and 80s with this as your main fear, one of the biggest movies that you can look up somewhere is called The Day After. And there are several others. I watched like 5 over the summer. But they were really interesting. The Day After was a movie that came out just on TV, and everybody was so... I mean, this was such a common thing that everyone was afraid of. About 2 out of 3 people that were alive in the United States when that came on TV actually watched it. So 2 out of every 3 people saw it when it first came on TV. You can't say that about anything these days. So it's interesting. I'd encourage you to take a look at that sometime. So, intercontinental ballistic missiles, it's a sort of thing that you want to make sure doesn't happen. And that's what we're working these days to prevent with other things that actually can intercept them before they cause damage and harm. Okay. Write down Project Mercury goals and write down the 2 bullet points.
Can I go to the restroom?
Sure. There you go. Yep. As you finish up this slide, just kind of thinking back to some of those movies too, it's scary to think about because it's not like now we look at it as almost science fiction, but back in those days that was a big fear that everybody had. You know, someone presses the wrong button and the world basically explodes. Like not literally explodes, but because it's not so much about people getting caught in the actual explosion. You're a lucky one if you're caught in the explosion because you die quickly. But radiation poisoning would get a huge amount of other people, and it's awful to just see what happens. How many of you guys actually saw the play that we did here? I think it was last school year, right before the pandemic. These Shining Lives, yeah. And that's a good, documentation of what happens with radiation poisoning. And just imagine that happening to society at large, where people and farmers and everybody that's supposed to get you the stuff you need to survive start dying one after another. And it's something else. It's a different mindset. So I'd encourage you to watch at least one of those movies at some point. You can find them. You can find several of them free, I'm sure, online.
Mr. Have you ever played Fallout?
I think that was one of them I watched.
No, it's a game.
Oh, it's a game. Okay. I don't think I've ever played it, no. So, in terms of the Mercury program, now that we're talking about actually putting humans in rockets instead of nuclear weapons, which is a nice thing, Mercury was the first to do that. And now we look at, putting humans in space as something that was really, really easy. But as everything else, it had the first time, the first time we did it was novel. It was new, and there were a lot of things that could go wrong. And Mercury was that first time. You can see there's one person in here, barely enough room for him. And this is the capsule that went on top of that rocket. And go ahead and write this down. Alan Shepard, first American in space. You don't need to know the year. Nah, just Freedom 7. I mean, it should be kind of an indentation from the Project Mercury main slide from before. Yeah, know that all this stuff is Project Mercury until until I changed course. Spacesuits looked a little different then. They are very shiny. And when we put Alan Shepard in space here, it wasn't like he was up there hanging out for a while. It was just a matter of going up. You're in space for like, I don't know, a minute or two, or maybe 15 minutes. I think the whole mission was 15 minutes. Getting him up, he was in space for maybe a minute or two, and then it just kind of came back down. It was like a parabolic thing. So that was step 1. This was step 2. After you get a person in space, you got to make it so they can actually successfully orbit the Earth. Write down John Glenn, first American to orbit the Earth.
How come it's always the seventh one that does it?
I don't know. That's a good question. Now, one of these, capsules, when it landed back on Earth, I think it might be this one, actually started filling with water, and he was able to get out before it sunk. But this one, I believe it was this one, is actually recovered from the ocean bottom after several years. So yeah, lots of little things that had to get worked out from these missions. All right, Project Gemini. Write down Project Gemini goals. Yeah, do the whole thing. Now, all these missions and all these goals were done with the idea that we would get a man to the moon by the end of the 60s. So these were all just steps to get to that final result. It's not like we said we want to put a man in space, and then later we said let's get someone to orbit the Earth and do all this. It was all done with the idea that we'd get to the moon. Probably the price tag. It's pretty expensive. Although, from what I know, we are planning on going back to the moon and landing there in 2024. I think the plan is to land at the south pole of the moon. So, it'd be kind of interesting for folks watching 4 years from now if that became if that actually happened or not. But that's the plan right now. And in terms of going to Mars, well, we'll talk about that next time. Because there is a plan in place from some rockets that are newer getting to Mars. But yeah, more on that tomorrow. So Gemini is named after the constellation Gemini. And you can see there's two people in there. And if you know or remember much about the constellation Gemini from our presentations, it's a constellation that has twins. So that's why they called it Gemini when you've got two people in there. Pretty cramped space. Write down Ed White, first American to walk in space. You don't need the year.
You don't need.
And all this means is he was attached to a cord and he left the capsule. He hung out in space for a while and he came back in. And there's a picture right there. And when you leave the capsule, you're just floating out there because you and the capsule are all falling around Earth's curvature. You're all orbiting the Earth at the same rate. So it's not like you're going to get pulled away unless you push yourself away from the capsule.
That's why the cord's there.
What's that?
Right? That's why the cord's there.
Yeah, just, yeah.
Once you start moving, you won't stop.
Yeah, you're not going to get back if you start moving away. Yep. You can't swim your way back. You don't have to write this down, but Buzz Aldrin set the EVA record that held for a long, long time, 5 hours, 30 minutes. What's that? Right now, I actually don't know what it is. Oh, EVA just means you're outside the capsule. You're spacewalking. You're floating out there.
Out there for 5 hours?
Yeah, I don't know if... I think that's... I guess that might be his total time, like, out there. Maybe it wasn't all at once. It probably wasn't all at once. There he is. And there's the inside, you can see.
You like, what is that in a museum?
Yeah, it's in a museum.
Do you know which one?
They're at different ones. I visited, I think it was the Friendship one, and that one was in, I don't even remember the state. It was in the Midwest somewhere,
Oh,
though.
really?
Yeah. So these aren't just along the east or west coasts.
I
Yeah.
just thought, well, this Houston is like,
I wouldn't be surprised if,
Florida's where like Washington.
yeah, I'm sure there's a ton there. I wouldn't be surprised if they maybe had a replica at the Chicago Museum of Science and Industry. But,
Oh, I heard that place is cool.
yeah. All right, so now we land on Apollo. Write this down. Gemini successfully completed orbits, docking maneuvers, and all that, because you need to do that if you're going to use a separate stage rocket in order to get to the moon. So when that was all successfully completed, we really started trying to get to the moon in earnest. Yeah.
All these pictures of the staff you're showing me remind me of that one where they died. Have you seen that one?
From the Challenger, you mean, or
No.
Columbia?
No, it was some country. They actually died in space.
Oh, yeah, that would be Russia. The Russians have lost a fair amount of people in space.
Why did
They made a stink. Like,
Yeah, the one that I remember was, and I think there were several accidents, but the one that really kind of got to me was the capsule depressurized before re-entering the Earth's atmosphere. So, well, all the air got sucked out, and you basically had a vacuum in there. So they went through that whole process of probably feeling their blood boiling and all that. It was probably a horrible, horrible way to die.
when you swim up too fast?
That's a little different, but it's the same thing with pressure, yeah. You get the bends. And that you get like bubbles in your bloodstream, and that can be a bad issue. But yeah, with this, they had recovered the Russian capsule, and they thought everybody was going to be alive inside. Because when you go through, when you start falling to Earth, and your heat shield kicks in and everything, you lose radio contact. And they were still alive when they lost radio contact. It wasn't until they opened it up and found, the dead cosmonauts in there. Yeah.
and then it's all good, and then the seeds, oh no.
Right. So yeah, you got to keep those things pressurized. Otherwise, it's just like being out in the vacuum of space. You're not going to last longer than a couple of seconds. Okay, so this is the basic structure of your Saturn V rocket. The main thing here is that most of this is all just propellant until you get up here. That's where you have the people, and right here you've got the LEM, which is the thing that would land on the moon's surface, and then rocket back up in order to reconnect with the command module. You saw that in Apollo 13. Write this down. A little bit of trivia there.
Is that the one you have in the back of the room?
Yes.
I'm not doing that.
What's that?
So that's not 300.
No, it's like 360.
One third at all.
Yeah, do the whole thing. It's hard to imagine how tall this is. I have stood next to one, and my goodness, it's just insanely massive. Well, I went to visit I actually went to space camp when I was real little.
Oh
So, yeah.
my god.
And I got to see those giant rockets and everything, and it was a good time.
You know, my uncle was just at the last space, the last rocket launch.
Oh, really?
Most recent one.
Oh, that's awesome.
Because, so he, you know what holding the football means?
No.
As far as, like, the president and stuff. They hold, like, the launch codes for...
Oh, I
He
see.
does that.
Okay.
So he follows the president.
Oh, that's interesting.
Yeah, so he's there.
Cool. Actually, I say really little. Actually, I did it when I was in high school, so I wasn't really little. I think I was a sophomore. And that's actually where this came from, too. So. But yeah, really, really fun. That was a good time. What's that? Yeah, I know, right? And this is big on me. But the thing back then in the 90s, everything was really baggy. That was the style. So I suppose I'm in style for that period of time. That's right. That's right. We'll pick it up here next time, I think. That was a fun trip, though, I'll say. My dad and I drove down there, and it was a fun little adventure.
Oh, well, like,